descent. Batch gradient descent function. In a case, once we will consider m number of houses, or you can say examples. Let me introduce how we can consider this. In this situation, we are considering this partial, our partial, okay, such that this is a cost function. We are considering the partial derivative of this cost function like a batch gradient descent. As I told you, this is for the gradient descent purpose. Here, basically, there are too many partial derivative with respect to theta, partial derivative of cost function with respect to theta 1. Similarly, partial derivative of cost function with respect to theta n. So all this, of course, belong to n plus 1 system. So batch gradient descent, okay, for number of examples, for number of features. In this situation, the same thing, okay, same thing, nothing changed. This weight parameter can be written like but here the situation is n plus 1, and of course in this situation you are considering the m number of examples. In superscript, I told you in start that we are considering the number of houses, m number of examples. So you will apply this cost function hypothesis, that is you are at theta of x instead of one simple, it should kind of theta x transpose, and this basically x is representing the n number of examples. Then it is the batch. From it, you can notice from this. And once you are dealing this, of course, you can write this such that you can write here x1, x2, xm, it depends, but you can notice here the transpose, that's fine. And of course it is telling you some kind of thing at theta, or you can say x1 at theta. Sorry, this one is a subscript, not I accidentally right. Theta, so this is the system, or you can say technically it is this system. And in this system, once you will deal, then of course your prediction, your actual values of the houses. Why? y will also be like this. So first example, second example, each house will have different actual price according to its material, according to its land. Okay, you want to guess it, guess features, its actual price. This is not the predicted one. Okay, so this one, you will also have this one. And of course, your hypothesis function, your complete hypothesis function, or your cost function. Cost function, I will start in simply, if you can say, it can be written like minus y, but for better accuracy, or you can say that it's we can non-value I will consider later, but of course it can be written like h x1 y1. Similarly, there are too many things, and you can write h theta xm minus ym. So this is just for external batch expression. I am just going to expand it further. Once you will have this setup, of course your scale norms value. From where we get norm value? From the concept of inner product spaces. Inner product spaces. Usually notation used for inner product spaces. In your textbook you can say x, or you can say x, it gives you kind of x scale, or basically it is the kind of a dot product thing, but usually it is written, or in the situation sometimes they are using the bar like things on it. You can say what is the difference between inner product and the dot product. Dot product basically do not consider the complex value, but inner product deal even with the complex value. I will speak out later about this, but the concept is this. So you are, if we are talking about two, okay, here this one, this, we are taking the inner product of this. So we will write x theta weight parameter, okay, minus y. I told you, you should not confuse, worry if we sometime I write x theta, sometime I write x transport theta, x theta transport. You should not worry. So we can write x theta minus y transpose here. Okay, this is the inner product. That is some, I told you that x transpose, basically we are multiplying, okay, to in the fashion of dot product, but this is also deal with the complex values. So you can write here by if we consider this by summing up all the values, then of course it is giving n number of examples. You can say I equal to 1, of course m number of examples, and it will becomes a scale. Okay, if you recall your memory, sometimes you say z, okay, or transpose, it gives you some kind of a scale value in your intermediate or OA level classes, early classes. I'll explain it later, but you can write it here like x theta minus y scale. Okay, the norm scales. Okay, from where we get the norm scale? Simply is another scenario, but here is another scenario. So this is what? This is actually h of theta, okay? X, or you can say the same thing. Okay, same thing. You are getting difference or some kind of a scale, least scale basically. Least scale things, of course, summation of this and I equal to 1. So this is what? This is simply the cost function. This is simply the cost function, j of theta. So for training them, okay, you can also consider the number of features along with it. This is the one thing, and once you are considering the gradient descent of this cost function, then of course, as I told you people, that you can consider the 1/2 intentionally, okay, and the rest is next part. This scale, now I am splitting it again for you people. This scale, okay, what I made here, this scale basically can be written like this. I am using this one, this expression, and once I will use this expression here, it will become theta x minus y, theta x minus y transpose. Please don't mind, instead of scale, I used this notion, okay, of transpose, inner product functions like this. And once I have this expression, okay, so I am considering 1/2 on a side. I am multiplying these two, or you can say, once I will multiply these two, then I will write x transpose x theta, because this one is of transpose. I multiply this first okay variable, then I got this result, minus, if multiply this and this, then we will get here y without transpose. And again, okay, we can consider this y multiply with this one, okay, then we can write y transpose theta x, and y negative sign will become positive, and we will have y transpose y. Hope you will not mind. It's very simple. Is it clear, please?
Yes.
Okay, one more thing, okay, associative property here. In start somewhere I mentioned you can write theta transpose x equal to theta x transpose, even you can write x transpose theta, it does not matter, okay. So here the order here, okay, it does not matter. Well, let me, for example, these two, okay, are the same thing. These two values become minus, okay, let me here write here.
ये थीटा टी किधर गया है सर?
Where?
ये जो ऊपर थीटा टी था
Where?
ये,
Okay, 1 plus 1.
क्योंकि उस पे टी नहीं था.
Yeah, I told you that
property z
okay, I told you. So we add up. So here square.
Okay.
So now this will becomes 2. Okay, this one, okay, one coefficient. So 2 value of this, and again here we will have plus y transpose y. I hope until here is clear to all of you, please.
Yes sir.
Now things become very simple and very good. So you can consider here again in the refreshed form that x transpose x theta square minus 2 x no, in the previous case, okay, theta. Yes, this, okay, for simplicity purpose, I consider this theta transpose only theta, okay, not theta, and x transpose y, or even just I can write here x theta y. Okay, just forget about the transport here, transpose minus y transpose y. We can write it like this. Actually, I want to get a partial derivative with respect to simple theta. So here is also theta, here is also theta. So I get rid of the transport, so you should not be confused. Until here it's clear? Because in the previous equation you can notice the theta transpose, x transpose, but I get rid of this transpose, so here this now is okay, just I consider it's a simple one. So now apply the partial derivative to it. This is kind of a constant thing, no man. This is constant thing. We are not differentiating it. Okay? 1/2 x transpose x can be written, okay? Partial derivative
2 theta.
clear?
Yes, sir.
Minus 1/2 as it is 2. Okay, come from here
2
x
y
y one thing and
theta.
partial theta over theta 1. I don't want to write.
Okay.
Now there is no involvement of theta, so 0.
0.
And this is what? This is, you can notice, this is gradient descent of that function j. So j. We can get rid of this 2. This 2, of course, will be over, and we will have
X t
j x transpose x theta minus x y. Any objection until here, please?
no, sir.
Clear, please? Okay. Now we almost attain. Once we want to determine the salary, okay, recall the memory about the minima. Okay, every person once will get his her salary, the remaining amount in the bank, or you can say change almost 0. So change, okay, this change, forgetting the global minima, global maxima, we need to consider it equivalent to minimum value or almost 0. First, in your intermediate OA level study, you consider first order derivative equal to 0, then you get the value. Remember or not?
Yes, sir.
If not, then I will explain in another section, okay? Please. So, consider this value equal to 0. So, our this equation, 0 theta transpose, I don't remember theta transpose. Okay, sorry, x.
X transpose.
I'm so sorry. I am not too young like you people. So minus x y. Okay, so you can write it like here, because the important thing, we want to know the theta. In hypothesis function, features are known to us. Important thing, we want to know the theta, so that we can use in updating iterative process. Okay, we can counter, we can start some function in the, see this value of theta will be used where? In the normal equation, where we will update the process, the iterative process, theta, we will start our business, we need to, this is the intercept value. Okay, we will start our business from the point. Okay. So we will consider this, okay, on the one side and other side, okay, so can be written like this. Any objection, please? Yes.
फिर से हमारा 12-15 में
Oh, okay. Just last second, please. I am so sorry. You are still integer. So you can write x transpose x inverse x
Y.
y. This is your pseudo inverse.
Oh, this is pseudo inverse.
Yes, yes. I will explain it in detail. Okay, later. I will explain this is the value of theta weight parameter in my next lecture.